Okay, this is the lecture video for lesson 15-2, which is part of the activity 13/15 video series, which you'll have a test on. So, last video we introduced quadrilaterals and did kites, okay? So, 15-2 is trapezoids. Okay, so we will be developing properties of trapezoids and then applying those properties. Those are our learning targets. So, what is a trapezoid? A trapezoid is a quadrilateral with exactly one pair of parallel sides. So if you notice, what I'm writing this inside of is a trapezoid. Our pair of parallel sides are the top and the bottom. The other two obviously are not parallel. Okay, so let's go about talking about the parts of a trapezoid. Okay, the parallel sides of a trapezoid are what we call the bases. So this is a base, and this is a base. The non-parallel sides are what we call the legs. So this is a leg, and this is a leg. All right, and then we have some angles, okay? We have two pairs of what we call base angles, and they're the angles that at each base forms with the leg. So, say angle 1 and angle 2 up here would be one pair, and then angle 3 and angle 4 on the bottom would be another pair of what we call base angles, okay? All right. Let's talk about the median of a trapezoid. The median of a trapezoid is the segment with endpoints at the midpoint of each leg of the trapezoid. Okay, so if I've got this trapezoid, all right, and then I take the midpoint of each leg and I draw a line between it. This is what we call a median of a trapezoid. Okay, again with the midpoints, okay, so that's important stuff to remember. So let's go look at our trapezoid median theorem. All right, the median of a trapezoid is parallel to the bases, and its length is half the sum of the lengths of the bases. Okay, it's a lot to say, so let's kind of break it down with this example right here. Given trapezoid EFGH, and MN is a median of EFGH. Okay, what that means is that M is the midpoint of EF, and N is the midpoint of GH. Okay, the trapezoid median theorem says that MN is parallel to FG, and it's also parallel to EH. All three of those are parallel. Okay. Also, we can say that MN is equal to half whatever you get when you add up the two bases, which are FG and EH. So as we're going to be setting up equations and solving problems, I want to write this a different way. It's a little bit easier. We're going to say that 2 times the median, which is MN, is just equal to the sum of those two bases. And I'd rather us use this formula. I know I made these notes and everything, but I like this formula better. So essentially what I'm saying right here is that if I know the lengths of the two bases, say this is 12 and this is 4, okay, to get my second base, to get my median, I can do 12 plus 4, which will give me 16, and then just divide that by 2, and that'll give you your median, which is 8. Okay, so if you're given the two bases, add them up, divide by 2. That's kind of like the average of the two. Okay. All right, P1. Given trapezoid EFGH, which we have right here, do the following. If the measure of angle GFE is 42 degrees, so GFE right here, 42 degrees. Let's find NME first. NME, which is this angle. So I know that all three of these are parallel. So I have two parallel sides cut by some transversal right here. These are corresponding angles, so that means this angle NME will also have to be 42 degrees. Okay, so now we're trying to find MEH, which is this angle right here. So this, in this case, two parallel lines cut by a transversal. These two angles are supplementary because they're same side interior angle, so we take 180 minus 42 to get that, this will be 138 degrees. Alright, cool. Now, write an equation to solve for x. If FG is equal to 4x plus 4, EH is equal to x plus 5, and then MN is just 22. Let's write an equation to solve for x. So I'm going to use this equation right here. 2 times my median is equal to the sum of those two bases. So add my two bases up, which are FG and EH. So 4x plus 4 plus x plus 5. That's equal to 2 times my median, which is 22. Now let's solve. So we have 5x plus 9 is equal to 44. 5x is going to be equal to 35, so x is just equal to 7. And that's all we wanted. That's all we were asked to find is x. So we're done. All right, part C. Find FG. So I'm going to go ahead and erase all this stuff right here. Okay. All right. So find FG if we know that MN is 19 and EH is 12. Okay. So how about we call FG just x? All right. So I know that I'll say that x plus 12, adding my two bases up, is equal to 2 times the median of 19. Okay, so x plus 12 is equal to 38. Okay, so x is just equal to 26. So that means FG is equal to 26. Okay, we can check ourselves to make sure we got that right. 26 plus 12 is equal to 38 divided by 2 is 19. And awesome, that's what we were hoping to find. Alright, number 2. We have this trapezoid, and we know that UV is the median of the trapezoid. So U and V are midpoints. Okay, so we're trying to find QU, we're trying to find VS, and we're trying to find UV, the median. Okay, so since U is the midpoint of QT, if UT is 3, this also has to be 3. Similarly on the other side, VS is going to have to be 4. A lot of people are making mistakes saying that QU is going to be 4 because it looks like it is. Remember, we cannot assume anything based on that. We have to take what we are given. The logic of that has to be able to go over to here, and that's what we're going to do. You make decisions from the math and the words that you're given, not how the picture looks. Okay, so QU is 3, VS is 4. All right, to find UV, add up my bases, divide by 2. 11 plus 15 is 26, divided by 2 is 13. So UV is just 13. And that's finished, that one. Okay, cool. Moving on to isosceles trapezoids. So this is this is what you usually think of when you see a trapezoid, okay? It's a very special case, not a very special case, but it's a very pretty case. What you see whenever you think of a trapezoid is going to be probably an isosceles trapezoid. So an isosceles trapezoid is a trapezoid with legs that are congruent. So if we look at my picture right here, I have my two parallel sides right here, and then my legs are in fact congruent, meaning that they are the same length. Alright, so we have trapezoid TRAP. What we just looked at is an isosceles trapezoid with bases RA and TP. My properties of isosceles trapezoids, those you'll need to know those as well. Each pair of base angles of an isosceles trapezoid is congruent. Okay, so my base angles are the two at the bottom and the two at the top. We can say that these two are congruent and these two are congruent. So we can say, how about angle T is congruent to angle P, angle R is congruent to angle A. Awesome. So next it says the diagonals of an isosceles trapezoid are congruent. So I draw these two diagonals. So these two lines I've drawn are congruent based on that. So those two lines are written as RP being congruent to AT or TA, whatever you want to say. Okay, now let's do number 3 that deals with isosceles trapezoids. Isosceles trapezoid CDEF with the measure of angle C equals 65. We want to find the rest of the angles, okay? I know my base angles are congruent, so this is 65. Angle F also has to be 65 degrees. Okay, now these two angles will always be supplementary. I know we didn't talk about that, but they are. Consecutive angles between the bases are supplementary. So this is going to be 180 minus 65, which will give me 115. Yes, 115. And then this one's also 115. And that's easy as that because we know the base angles are congruent. All right, our last problem here. This one looks hard, but I promise you it's not because we know a lot of stuff. So let's read what it says. EF is a median of an isosceles trapezoid ABCD. That's a lot of information in just one sentence right there. It's a median, so I know that E and F are midpoints, so I know that these two are congruent. For sure, these two as well, on the right. But it's an isosceles trapezoid, so I know that AD is congruent to BC. So if I have midpoints that are splitting up two congruent sides into two congruent parts of those sides, what that tells me is that all 4 of these segments are congruent, which is a really cool thing. It's going to make solving our problem much easier. Okay, so we're going to solve for x first, however, then we'll get to the y, okay? So we know that ED is a median, so I can say that we add up my two bases, 8x minus 43 plus 10 is just equal to 2 times my median, which is 2x. So let's solve. 8x minus 33 is equal to 4x. So 4x is equal to 33. Doing a little skipping steps in algebra in my head. So x will be equal to 33 divided by 4 is going to give me a decimal number, and it'll be a pretty clean decimal, so we'll actually write it as a decimal. It's going to give me 8.25. I'm okay with that because it rounds nicely. All right, let's do y now. All right, since I know that all 4 of these segments that I marked are equal, I have an equation that I can set up. How about 6y minus 1 is just equal to 2y plus 3. So subtract 2y from both sides, get 4y, add 1 to both sides, we get 4, so y is equal to 1. All right, AE. To get AE, we just plug in 1 for y, so 2 times 1 plus 3. 2 plus 3 is 5. All right, since I know AE is equal to ED, BF, and FC, the next 3 blanks are all 5. That's very handy and very easy there. Okay, AB, to find AB, we're going to plug in 8.25. 8 times 8.25 minus 43. So 8 times 8.25 is 66 minus 43 gives me 23. And then to find EF, plug in 8.25 again. So 2 times 8.25 is just 16.5. And guys, that is the lesson on trapezoids, okay? That's all we got. We spent about less than 15 minutes doing that. So guys, if you have any questions, of course, email me on that. And if not, happy studying for the quiz that you'll have coming up on activities 13 and 15. So we'll have 2 more lessons left after this. So there'll be 2 more videos after this video. Again, if you have any questions, let me know. Thanks for watching.